In this very video, we are going to be looking at the relationship between the root and the coefficient of a quadratic equation. Okay, remember we earlier on we said that the roots of a quadratic equation are the solutions to the quadratic equation. So here we have let alpha and beta be the roots of a quadratic equation. If the root of this equation is alpha plus beta, then the sum of the roots, which is alpha plus beta, is minus b over a, and the product of the root, which is alpha beta, is c over a. Okay, so we see an example here. Let's say alpha and beta are the roots of this particular equation. We ask to find the sum of the roots, which is alpha plus beta, and the product of the roots, which is alpha beta. Okay, first of all, we start with a. Your a is the coefficient of x squared, which is 2. Your b is the coefficient of x, which is minus 3. And your c is the constant coefficient, which is 4. So that means alpha plus beta, which is minus b over a, is going to be minus 3. Your b is minus 3 over your a is 2. So that gives us 3 over 2. Okay, then alpha beta is c over a. And your c is 4. And your a is 2. And that is going to give us 2. Okay, so that means the sum of the roots of that equation is 3 over 2. And the product of the roots of the equation is 2. So let's see an example here. So here we are given this equation 4x squared minus 5x plus 2. And then we are asked to find the whole of this. Now, first of all, I would like to note that finding the whole of these quantities is not possible without knowing the sum of the roots and the product of the roots. Now, let's write out the coefficients. You see that your a here is equal to 4, the coefficient of x squared. Your b, the coefficient of x, is minus 5, and your c is equal to 2. Okay, so if we have alpha plus beta, the sum of the roots alpha plus beta, like we say, is minus b over a. So this is going to be minus 5 all over 4. Your b is minus 5 over 4. So your alpha plus beta is 5 over 4. You can write that down somewhere. Then your alpha beta is equal to c over a. Okay, your c is 2, your a is 4. So that's going to give us 1 over 2. You can also write that down somewhere. Alpha beta is 1 over 2. So let's go ahead with finding the quantities. Let's start with the first one. We have 1 over alpha plus 1 over beta. We can start by finding the LCM, which is alpha beta. And when we cancel out, alpha cancels alpha, you're going to get beta plus alpha. Okay, which is the same thing as alpha plus beta. Now remember, alpha plus beta is 5 over 4. So we have 5 over 4 divided by alpha beta is 1 over 2. So that's going to give us 5 over 4 multiplied by 2 over 1, which finally is 5 over 2. So 1 over alpha plus 1 over beta is 5 over 2. Now let's go on with the next one. The second question here, we have 2 alpha squared beta plus 2 alpha beta squared. Now the best way to represent this in terms of alpha and beta is to factorize. You can see common factors there. We have, I think here 2 alpha beta is common, so you have 2 alpha beta. Now when you factorize 2 alpha beta here, if you remove 2 alpha beta here, 2 cancels 2, alpha cancels alpha, beta cancels beta, alpha cancels 1. So you have alpha plus. The same thing here, if you factorize 2 alpha beta, 2 cancels 2, alpha cancels alpha, beta cancels one of the beta here. So you have beta. So in substituting value now, this is going to be 2 times your alpha beta is 1 over 2, and your alpha plus beta is 5 over 4, which when we are done multiplying, our answer is 5 over 4. Okay, so that leads us to the next one, which is alpha squared plus beta squared. Now the best way to know to get the expression for alpha squared plus beta squared is by expanding alpha plus beta all squared. It makes the job easier. And expanding this now is going to give us alpha plus beta into alpha plus beta, which when we open the brackets, we are going to get alpha squared plus beta squared plus 2 alpha beta. So if we want to make this the subject of formula, we are going to get alpha squared plus beta squared now is going to be alpha plus beta all squared minus 2 alpha beta. Okay, so let's start all over there. Alpha squared plus beta squared, we just found out, is the same thing as alpha plus beta all squared minus 2 alpha beta. Okay, so my alpha plus beta, which is the sum of the root, remember, is 5 over 4. So we have 5 over 4 squared minus 2 alpha beta. Alpha beta is 1 over 2. So that is going to give us 25 over 16 minus 1, okay? And that is going to give us 9 over 16. So your alpha squared plus beta squared is 9 over 16. I would suggest you write that down because we can use it in some other cases. Now, the next one is alpha cube plus beta cube. We can get that by expanding this using the binomial expansion, either Pascal's triangle. Alpha plus beta cube is going to give us alpha cube plus 3 alpha squared beta plus 3 alpha beta squared plus beta cube using binomial expansion. Okay, so if I want to make alpha cube plus beta cube subject of formula, it means I'm going to get alpha cube plus beta cube now is now going to give me alpha plus beta all cube minus 3 alpha squared beta minus 3 alpha beta squared, which you can still represent as alpha plus beta all cube minus 3 alpha beta into alpha plus beta. So now let's do well to substitute value. We write that again, that alpha cube plus beta cube is equal to alpha plus beta all cube minus 3 alpha beta into alpha plus beta. Okay, so your alpha plus beta like we have is 5 over 4. So we have 5 over 4 cube minus 3 alpha beta is 1 over 2. Alpha plus beta is 5 over 4. Okay, and if we multiply that now, that's going to give us 125 all over 16. Sorry, 4 cube is not 16. 4 cube is 64. So let's make that 125 all over 64. Minus this is going to give us 15 over 8, and that is going to give us 8 times 15 is going to give us 120. So the whole of that answer is going to be 5 all over 64. So 5 over 64, alpha cube plus beta cube is 5 over 64. Now that leads us to the next one, which is alpha cube minus beta cube. Now if we use our number long division factorization to factorize this, is going to give us alpha minus beta and alpha squared plus beta squared plus alpha beta. But we can't use this here since we don't know what alpha minus beta is. That's something on its own. So let's do that. And alpha minus beta is actually number 5. So let's do that separately. We have alpha minus beta. We can get it from alpha minus beta squared, which we know when we open the bracket, we are going to get alpha minus beta into alpha minus beta. So opening the bracket here will give us alpha squared minus 2 alpha beta, then plus beta squared, which means that your alpha minus beta now can now be square root of alpha squared plus beta squared minus 2 alpha beta. That makes it easy. So let's do that. We have alpha minus beta now is equal to square root of alpha squared plus beta squared minus 2 alpha beta. Okay, if we do that, we are going to get square root of, remember we have alpha squared plus beta squared to be 9 over 16. So this is 9 over 16. Then minus 2 times alpha beta is 1 over 2. Okay, so that is going to give us square root of 9 over 16 minus 1. And that is going to be square root of minus 7 over 16. Okay, so that is what we get there. Now it leads us to the next one. You can write that down somewhere, that alpha minus beta is square root of minus 7 over 16, or you can as well write it as square root of minus 7, which is a complex number, all over 4. Minus 7, square root of minus 7 all over 4. So now let's go with the other one, which is alpha cube minus beta cube. We said is same thing as alpha minus beta into alpha squared plus beta squared minus alpha beta, actually plus alpha beta. So when we factorize this is exactly what we are going to get. So our alpha minus beta is already root minus 7 all over 4 into alpha squared plus beta squared like we had before is 9 over 16 plus alpha beta is 1 over 2, and that means square root of minus 7 over 4 into This is going to give us 17 over 16, and you can use your calculator to do that, or we can just write that. That will give us 17 root minus 7 divided by 4 times 16 is 64. So that's the answer to that very question. Now we see the last one here. We have 1 over 2 alpha minus beta, okay? Now plus 1 over 2 beta minus alpha. Here we can find the LCM. The LCM is the duo, which is 2 alpha minus beta and 2 beta minus alpha. Okay, so which is going to give us 2 beta minus alpha plus 2 alpha minus beta. Okay, so if we add up the numerator, we are going to get minus alpha plus 2 alpha will give us just alpha, plus 2 beta minus beta will give us beta, all over. If we open the bracket down there, we're going to get 4 alpha beta minus 2 alpha squared minus 2 beta squared plus alpha beta. That means the whole of this can now be written as alpha plus beta all over. 4 alpha beta plus alpha beta will give us 5 alpha beta, then minus 2 into alpha squared plus beta squared. Okay, you can write that down somewhere. Alpha plus beta over 5 alpha beta minus 2 into alpha squared plus beta squared. So now let's substitute our values. We write that again, alpha plus beta all over 5 alpha beta minus 2 into alpha squared plus beta squared. Alpha plus beta, remember, is 5 over 4 all over 5 times alpha beta, that means 5 times 1 over 2, then minus 2 times alpha squared plus beta squared. Remember, we got that to be 9 over 16. So this is going to give us 5 over 4 divided by 5 over 2 minus 9 over 8. 2 can go in 16 to give us 8. And that is going to give us 5 over 4 now divided by 5 over 2 minus 8 is going to give us 11 over 8. Okay, so that means we are going to have 5 over 4 times 8 over 11, which when we cancel is going to give us 10 over 11. So the answer to that question is 10 over 11. Now that leads us to more question on that. We see this question. It says we should find the value of k if one of the roots of 3x squared plus 5x minus k equal to 0 differ by 2. Okay, sorry, if the roots, not one of the roots, if the roots differ by 2, that means the difference between the roots is 2. Okay, so let's see. We can say that our a is 3, which is the coefficient of x squared. Our b is 5, which is the coefficient of x. Our c is the constant coefficient, which is minus k. And since one of the roots they differ by 2, that means the difference between the roots, which is alpha minus beta, if alpha and beta are the roots of the equation, is equal to 2. Now alpha minus beta, remember what we say it is the same thing as square root of alpha squared plus beta squared minus 2 alpha beta, all equal to 2, which we can still expand further, which is alpha plus beta all squared minus 2 alpha beta minus 2 alpha beta all equal to 2. So that is going to give us square root of alpha plus beta all squared minus 4 alpha beta all equal to 2. Or you can say that alpha plus beta all squared minus 4 alpha beta is equal to 4 when you square both sides. So we can write that down somewhere. So the challenge here is to know what alpha plus beta is and to know what alpha beta is. And to do that, we can first of all find alpha plus beta. Alpha plus beta here is supposed to be minus b over a. So that will be minus 5 over 3. You can write that down somewhere. Then your alpha beta is equal to c over a, which is minus k all over 3. You can also write that down somewhere. So if we are to substitute, let's bring out our equation again. We had alpha we do that again. We are told that the equation x alpha minus beta is equal to the square root of alpha plus beta all squared minus 4 alpha beta. Then we are given that they differ by 2, so the difference is 2. So we have 2 equal to square root of alpha plus beta all squared minus 4 alpha beta, which when we square both sides is going to be 4 equal to alpha plus beta all squared, then minus 4 alpha beta. Okay, so if we substitute the value, we are going to get 4 equal to alpha plus beta we got is minus 5 over 3, so that's going to be minus 5 over 3 all squared, then minus 4 times alpha beta is minus k over 3. Okay, so you can write that down somewhere. 4 equal to minus 5 over 3 all squared, then minus 4 into minus k over 3. If we continue from there, we have 4 is minus 5 over 3 squared, then minus 4 into minus k over 3, which when we expand, we're going to get 4 equal to 25 over 9. Okay, then plus 4k all over 3. Which one will find the LCM here is 9. We have 25 plus this is going to give us 12k. So if we cross multiply 4 equal to this, we cross multiply is going to give us 36. So 36 equal to 25 plus 12k. If we collect like terms, this is going to be 11 equal to 12k. So that means k is equal to 11 over 12. Thank you very much. Please do well to subscribe. If you're yet to subscribe, click the subscribe button below. Have a nice day.